4.4 Polyatomic ions. Polyatomic ions are a group of atoms that have an overall charge. That's why it's called an ion. They often consist of a nonmetal like phosphorus, sulfur, carbon or nitrogen, and oxygen. And they usually have a -1, -2, or a -3 charge. Some common names of polyatomic ions that you might see a fair amount would be sulfate. Now notice these are anions, they're negatively charged, and notice the ending is no longer an IDE for an anion. And the reason is because this is a polyatomic ion. So we need to have a different ending, not IDE for the most part. So what they do is, the most common combination that oxygen has with sulfur is 4. Now, this ion is still a -2 charge, just like if we had sulfide. But because we have the oxygen there, the ending is sulfate. The same thing goes for our phosphate. Oxygen's combination with phosphorus, the most common one when making an anion, is 4. So they're going to call that phosphate. Now it's still an ion, it's not the overall compound or anything, it's an ion, it's charged, it's a -3. Now nitrate, NO3 with a -1 charge. That's not a typo. You might think it might be supposed to be like a 3. It's not. It's a -1 charge, or 1 negative charge, however you want to say it. Notice the most common combination with the sulfur and the P is the 4, and the most common combination with the N of oxygen is 3. Well, when there's one less oxygen with those items, they've got to change the ending of the anion, so they change it to ite. Notice, one less oxygen than normal for sulfate is 3, so we're going to call that ion sulfite. Same thing for phosphite, PO3, because it's one less oxygen than normal. Same thing then for nitrate, NO2 -1 is one less oxygen than normal, so nitrate ion. Here's a couple of other ions. You might have heard of some of them. Cyanide, CN with a -1 charge. Hydroxide, an OH with a -1 charge. Ammonium ion. It's NH4 with a positive. Notice that ammonium is the only one that has the positive polyatomic ion. Now, you've heard of, especially if you're in the medical field, you might have heard of bicarbonate or bicarbonate solution. Well, what a bicarbonate is, or a hydrogen carbonate, is we have our carbonate ion, CO3, -2 charge. When we add a hydrogen ion, it's HCO3 negative. Now notice, the reason why it's only a -1, not a -2, is the fact that when you add a hydrogen with a positive one, and 2 negatives end up overall a -1 charge. Well, let's say that we have different amounts of oxygens with these polyatomic ions than the ones we've just talked about. So we just talked about chlorate. We just talked about the ate ending and the ite. So let's look over there at the halogens. So we have the most common combination that oxygen has with the halogens, for example, the chlorine, is 3. It's a -1 charge, just like what you might predict. And one less oxygen than normal with the halogens is 2, so chlorite. Well, let's say you have even less than that. So you have 2 less than the original amount. That's hypochlorite. And you go, I've never seen or heard of hypochlorite. Well, go and look at the back of your bleach container, and you will see that you've got some hypochlorite in there, probably sodium hypochlorite. Now then, as we go back up here to the chlorate, if we had one more oxygen than what was normal, the prefix is going to be per, and then the item, chlor, and then ate. So it just makes it much easier if you memorize these polyatomic ions so that you recognize them and you see them, and it's helpful to know the charges. Otherwise, just kind of keep it on an index card right near where you're at so that you can look at it whenever you need to. All right. when we make compounds that contain the polyatomic ions, we need to use the same rules of charge balance as those for the simpler ionic compounds. For example, if we're going to make the compound magnesium nitrate, well, magnesium's in the second group, group 2A, it's a +2 charge. Nitrate, you memorized, as NO3 with a -1 charge. So we obviously need 2 nitrate groups. All right? Because 2 negatives is a -2, which balances out the 2 positives. So we need 2 of these units. Now we need to put these units in brackets right there and put a 2 after it. That way, if we didn't have these brackets, so mentally scrub these brackets away, if we only put a 2 right here without those brackets, it would look like we had 32 oxygens, and we don't have 32 oxygens. We have 2 nitrate groups. If you want to know the exact amount of oxygens there, then it's 2 times 3, which is 6. And it is 2 times 1 of the nitrogen, 2 nitrogens. But we look at this as a unit. We need 2 of those units. All right, select the correct formula for each. So pause it and see if you can do it. Aluminum nitrate. Aluminum is a +3. So that means we need 3 nitrates. So we would put that 3 right here to designate that we need 3 nitrates, because nitrate, remember, is a -1 charge. Copper 2 nitrate. Well, copper is a +2 charge. Nitrate's a -1 charge, so that means we need 2 of the -1 charges to balance out this +2 charge here. Hence, 2 of our nitrate groups. Iron 3 oxide. That means iron is a +3 charge. We know the hydroxide is a -1 charge, so we're going to need 3 of these units, since it's a unit, that's why we use the parentheses, to balance out the charge. Tin 4 hydroxide. Hydroxide's a -1 charge. Tin is a +4 charge. So we need 4 of these units. All right, the guide to naming ionic compounds with polyatomic ions. First of all, you identify the cation and the anion. You know, the polyatomic anion. Then you name the cation with a Roman numeral if it's one of those metals that can be more than 1 charge. And then name the polyatomic ion with appropriate ending, and then write the cation first and the polyatomic anion second, as long as the polyatomic anion is negative. All right, here we go. Name the following ionic compounds. Calcium nitrate. Iron is one of those that can be more than 1 charge, so we must look at phosphate. You've memorized that phosphate is a -3 charge. It's a 1 iron to 1 phosphate ratio, so that makes this iron 3 phosphate. Put it on pause and come back. All right, let's name each of the following compounds. You might recognize that SO something is related to sulfate. Well, SO4 is sulfate. This is 1 less oxygen than normal, so this is going to be sulfite, magnesium sulfite. Here's magnesium sulfate. Here's calcium chlorate. See if you can name these. Press pause and come back. Iron can be more than 1 charge, so we have to look at sulfate to figure out what's the charge. Well, we can do the math, or we can do the shortcut, the non-thinking way, with the 2 and a 3. We're going to put the 3 up here, the 2 there, which we know the sulfate's a -2, which means it has to be iron 3 sulfate. This is 1 less oxygen than normal for phosphate, so that means it's phosphite, barium phosphite. Lead can be more than 1 charge, so we have to look at the partner to see what its charge. That's carbonate, which is a -2 charge. It's 1 lead to 1 carbonate ion ratio, so it is, since it's overall -2 for the carbonate, that means lead must be a +2. So it is lead to carbonate. NH4 is the ammonium ion, and this is just chlorine with no oxygen after it. It's not a polyatomic anion, so it's just ammonium chloride.